So this was 1, 2. You could see something like number 1, number 2 on your quiz. You will leave it as a fraction. Like number 2, you would leave it as 13/6 instead of rounding it to a decimal. Number 3, you would need a calculator for. So tomorrow's no calculator on that quiz. It is 10 questions. It is multiple choice. Well, multiple answer for part of it, and then multiple choice for part of it.
Wait, so for 1 and 2 would be no calculator?
Correct. Same thing with 4. You would leave them as their fractions though. So 4a, b, c, well, I would make sure to reduce them. So they would, like this would be, you'd have to go 4/17, something like that, okay? It should be obvious. That would not be an answer choice. Like 8/34 would not be an answer choice. You would want to reduce it. But you won't take it to the decimal place like the next step. The estimate the rate of change will not be on the quiz, but it will be on your test. If you use negative 1.999 here, your answer is going to be a little bit off, like negative 7.9998, which is fine. It's an estimate.
Wait, you said the ones above 6 and 7 can be on our...
Correct, but they would be left. Wait, 6 and 7? No.
No, 6 and
4 would be, but they would be left as fractions. Yep. And then 7 through 10, you could see. Those don't need a calculator. Determining if they're positive, negative. Yep.
So the estimate rate of change of the function.
Just these, test, not quiz.
Okay.
And then this step of these where you take it to the decimal won't happen. But the rest of it is fair game. Your quiz is 1, 1 and 1, 2. Yeah. So for the quiz, you won't, because you'll leave it as as fractions. You won't have a calculator. If it was on the calculator portion of your test, you would do decimal. All right, then came your AP classroom. So I like number 3, I want to say was the only one that even had to have a calculator. So number 1, this is where you have to look at those intervals and then adjust them to figure out. Remember, this said which function increases the most. You would want to watch those wordings, like which one has the biggest change, which one has the biggest increase, which one has the biggest decrease. So you have to adjust it for its interval and then answer that question. You can't just look at those values. For 2, you were kind of just looking at the steepness of that graph. It said in which one has the average rate of change the least. So you're looking for the least change, which was that 1 to 2. 3. Yeah, this was your graph. It asked you to graph it and then determine what was positive, what was negative rate of change. For 4, and this probably, I got a question on it. It says, of the following, on the first day of which month is the rate of change of the temperature the greatest? So unlike the question that was in the notes where it asked of over the course of that month, which one had the greatest change, this is talking about on the first day. So if I want to know what's happening on the first day, I actually have to go to the month before it, right? Because then it would end on the first day. So for February, I had to go to see what was happening from January to February. For May, April to May. For August, July to August. And for November, October to November. So of those, May had the biggest positive rate of change. And then 5, and this one I would say is a little tricky. We haven't done combined functions. We will get to these. But the rule on combined functions is if you have a graph and you add them, let's say I was adding these 2 functions and I didn't know exactly what they looked like, but if I wanted to add these 2 graph functions, then this coordinate point and this coordinate point would get added together to get the sum. If I went over here, this coordinate point and this coordinate point would get added together to get the sum. What you don't know about this function is where it starts. This whole thing could be shifted below the x-axis, above the x-axis. So again, we will cover the adding, subtracting, and combining notation a little bit later. I think it's weird that they bring this question in here, but it is in this section. So I wanted to make sure we at least talked about it. But you don't know, you know from 0 to 5, it was a positive rate of change, right? No, wait. 0 to 5 had a negative rate of change. Then from 5 to 10, it had a positive rate of change, but you don't know where on your graph it is. If it was really low, it could pull the other function really low. If it was really high, it would pull the function up higher. So this one is, you don't know. It could be increasing, decreasing, or both increasing and decreasing on that. To me, this is a tricky question at this point. Like, if you got it wrong, don't freak out. I like remember this question from this part of the year last year because they hated this question because it's tricky. Okay, it basically is talking about your rate of change from drone A to drone B. And you want to see, like, what's true about their average rate of change? Are they equal? Is A bigger than B? Is A bigger than B? Is B bigger than A? Or can you not tell because the heights of you were not given the heights of the drones? Well, we are talking about a rate of change, so that last one doesn't work. So what you had to do is figure out if it started at positive 17. If my first change was 17, I went up to 17. You don't know where you started. But let's just say for drone A, you started at 0. Again, we don't know exactly. But we went up to 17, so we're up at 17. Then you went down 4, so now you're at 13. Then you went up 11, so now you're at 24. Then you went down 5, so now you're at 19. And then you went down 3, and so now you're at 16. So drone A would finish with a rate of change at 16. And B, wherever it started, which we're saying the same place, goes up 5, goes up 3, so now it's at 8, goes up 3 again, so now it's at 11, goes up 2 again, so now it's at 13, goes up 3 again, so they both finished at the same place. So if you went from 0 to 30, your rate of change would have gone from 0 to 16, they would have been the same. So this is like a perfect example of like an AP style question based on rate of change. It can be super confusing, okay? For me, this is not a quiz question. Maybe you see something like it on a test, but for tomorrow, you don't have to worry about this just yet, okay? Talk about your quiz. So this is the PDF quiz review, but we need to practice the lockdown, okay? You are taking this on, which I'm going to try to do sporadically throughout the year, a little bit of practice online because that's what your test is, right? Your multiple choice portion of your AP exam is completely digital. So the challenge will be not having a tangible piece of paper in front of you. You cannot draw on this graph. Like, I have to get you used to it. So we're going to start as often as we can. So we're going to get into that today. But this stuff, like this was all from 1-1. So like your independent, your dependent variables, and then all of these questions, you won't necessarily get all of these questions, but any of these questions can be asked about a graph. So you want to answer all of those parts for both question 2 and question 3. And then we got into the rate of change. So 5, 6, and 7 are all dealing with your average rate of change. On 6, I will say this, like these are decimals. So I wanted you to see the question because they will ask you stuff like this. You can use a calculator to get this answer, but just know if this was on tomorrow's quiz that this would maybe just say 1,000 and this would maybe just say 1,200. These would be numbers that are much more manageable without a calculator. Does that make sense? Okay. So I left you the answer in both decimal and non-decimal form, but on tomorrow's quiz you won't have a calculator, so you would leave it as the non-decimal part. Okay. All right. So these are all the questions that could be asked. Obviously, you're not going to get them all because these are a lot, and you only have 10 questions, and it includes rate of change. But these are what you could get asked. So you got to be prepared for any of these. So the zeros are where it crosses the x-axis, right? So in this case, it would be x equals A, C, F, and H. That is an all or nothing question. That's multiple choice. You get it right, you get it right, you get it wrong, you get it wrong. The y-intercept, and it could be answered as y equals I or 0I, because your x should be 0, could be either of those. Again, all or nothing. Then increasing and decreasing, we're talking about the actual graph. So it is increasing from negative infinity up to b, so x is less than b. And then it is increasing again from d to g. So d is less than x, which is less than g. And then again from h to positive infinity, so x is greater than h. So it will award partial credit on those, but you want to obviously get all 3 so that you get the full points.
You said these will be multiple choice.
These will be selected just like you did. Select all that apply.
You don't have to write them down.
No. Yeah. I'm gonna give you a piece of paper for the rate of change questions for scrap. If you wanted to draw this out so you could like manipulate it, you feel free. But obviously you can't draw on it, which is one of the things we gotta get used to. Yeah,
It's okay if we don't show work for that.
correct. Yeah. All right, then decreasing is from B, let me do a different color. B to D and G to H. So B is less than X, which is less than D, and G was less than X, which is less than H. Increasing and decreasing is the same thing as the rate of change being positive and negative. So increasing is the same as the rate of change being positive, and decreasing is the same thing as the rate of change being negative. That's not on your practice. That could also be part of it. It's on the quiz review, but it wasn't on today's multiple choice thing. So make sure you also know that those are the same thing, okay? Then rate of change increasing means that it is concave up, and rate of change decreasing means that it's concave down. Those mean the same, these mean the same. So rate of change increasing, we're looking for our U's and our N's. Increasing, we're looking for the U, which happened there, and it happens like on this side of this curve. So it would be rate of change increasing from C to E, and from X is greater than H. Then the rate of change decreasing, or your concave down, was here and here. So let me start in order. X is less than C, and it's in between E and, I just wrote on it H, right? That's what's there. So make sure you know that those mean the same thing. Concave up is the same thing as rate of change increasing. Concave down is the same thing as rate of change decreasing. And then your graph being positive, negative, this is where it's across the x-axis. Anything above it is positive, anything below it is negative. So above my x-axis is A to C, F to H, and H to positive infinity. So it would be A to C, and X is greater than F because it stays above it that whole time. And then below it would be C to F. So again, make sure you're ready for any combination of these things. That's a lot of options, and it could be any of them. And then obviously your rate of change questions and stuff from 1, 2.
Wait, increasing and decreasing.
Regular increasing and decreasing is literally going up or going down as you move from left to right. Rate of change increasing is concave up. Rate of change decreasing is concave down.
And then rate of change positive, rate of change negative is the same as increasing.
As increasing and decreasing, yep.
On the graph, so it just reflects
Yep.
the X or Y.
What do you mean, X or Y?
Like anything above the x-axis.
No, that's the graph positive, graph negative, right. So don't let the words throw you off.